Hello, welcome again. We are solving GATE 2017. Question number 18 is a turbine state which one of the following for a turbine state which one of the following processes occur due to turning of wall boundary layer through an a curved surface. Option A profile loss, option B annulus loss, option C tip clearance loss, option D secondary flow loss. So answer is D. So let us discuss what are these losses. So profile loss is associated with boundary layer growth over the blade profile. It is related to boundary layer growth over the blade profile, including the separation loss under the adverse conditions of extreme angles of incidence or high inlet mechanism. So at the adverse angle of incidence, at the extreme angle of incidence and at high Mach number, the separation occurs, which also leads to profiling. Okay. Second is another loss. The another loss is associated with boundary layer growth on inner and outer walls of the animal. So it is related to annulus. So there is nothing to do with the turning of wall boundary layer. Okay. Next, secondary flow loss arising from the secondary flows, which are always present when a wall boundary layer is turned through an angle by an adjacent curved surface. So this is the answer. So now tip clearance loss is near the rotor, it occurs near rotor blade tip, and the gas does not flow into the internal part and fails to contribute its quota of work output and interacts with the outer wall boundary layer. So it is related to tip of the blade. Okay. So answer here is option B, secondary load. The curve turning of the wall boundary layer through an angle due to curve surface is the load that occurs is called secondary load. Next, in a veinless space between impeller and diffuser vanes in a centrifugal compressor, the angular momentum varies in the following diameter in the radial direction. Option A increases, option B remains constant, option C decreases, option D first increases and then increases. So answer is remains constant. In the veinless space, no energy is imparted and no form of energy is changed from heat to heat. So angular momentum remains constant. So answer is option B. Next, question number 20. Which of the following statement about the neutral axis of a beam with unsymmetrical cross section is true? Option A, the product of second moment of area about the neutral axis is always 0. Option B, the normal stress along the neutral axis is always 0. Option C, the shear stress along the neutral axis is always 0. Option D, the product of second moment of area about the neutral axis and the normal stress about the neutral axis are always 0. So answer is the normal. In case of symmetrical or unsymmetrical bending, the normal stress is always 0 at neutral axis, but the shear stress is maximum. So answer is option B. Next, assuming that the aircraft is flying straight, the top scar cap oblique flange of a wing is most likely to fail in. This is the top scar flange. Option A yielding, option B building, B yielding, buckling, C crashing, and D creep. So this will air is coming like this, so it will be able to fail in buckling, and this like this. So it is a longitudinal section of this top scar. Air will act like this and this, so it will buckle. Next, question number 22. A 2 degree of freedom undamped spring mass system with two masses and two springs has natural frequencies omega 1 is equal to 0.71 radian per second and omega 2 is equal to 1.53 radian per second. The mode shape for the system is given by pi 1 0.722, 1 transpose and pi 2 minus 2.73 one transpose. If the first mass is displaced by 1 centimeter, the minimum displacement in centimeter to be given to the second mass to make the system vibrate in the first mode alone is dash in 3 decimal places. So as the first mode shape is 0.732 transpose. Okay, so it means if x1 is initial displacement of x1 is 0.732, then the initial displacement of x2 is 1. And now it is given that the initial displacement is 1, so corresponding initial displacement will be 1 divided by 0.732. Okay, because for 0.732 it is 1, and for 1 it is uh, 1 by 0.732 or 1.366 answer. Next, a single degree of freedom spring mass system of natural frequency 5 Hz is modified in the following manner. Case 1, viscous damping with damping ratio zero point 0.2 is introduced in parallel to the spring. Case 2, the original undamped spring mass system is moved to a surface with coefficient of friction mu is equal to 0.01. The ratio of the undamped natural frequency for cases 1 and 2 is given by dash in 3 decimal places. So, in case of damped vibration, the natural damped frequency is given by fn 1 by c, or fn is 5 root, and this is zero point 0.2, damping ratio is 0.2. So the damped frequency comes out as 0.7979 into 5. Okay. So in second case, as this is the case of Coulomb damping, and the coefficient of friction is given, but here the damped frequency and natural frequency are same in case of Coulomb friction. So that is that is 5 Hz. So the ratio of FD1 to FD2 is 0.979. Yes, answer is 0.979. Next, which of the following statement about the compatibility equations are true? P. The state compatibility equation must be satisfied in the solution of three-dimensional problem in elasticity. Q. 6 strains are defined in terms of three displacement functions and can have arbitrary values. R. Compatibility equations are an expression of the continuity of displacement. Option P and Q, option B Q and R, option C P and R, option D P, Q and R. So answer is C, that is P and R are correct. The Q is wrong because 6 strains are defined in terms of three displacement function and cannot have arbitrary value, they are dependent upon each other. Okay, so the arbitrary value is wrong. Okay, so answer is option C.